Every few years, someone stumbles across a field full of diesel locomotives sitting behind a chain link fence, weeds climbing the trucks, paint fading, engines cold. They look like forgotten machines. In a way, they are. But the decision to leave them there instead of selling them wasn't negligence, it was math. To understand why railroads abandon locomotives instead of selling them, you have to start with depreciation, because that's where the whole story begins. When a railroad buys a new locomotive, the IRS doesn't let them write off the full purchase price in year one. Instead, the cost gets spread across several years under a system called Modified Accelerated Cost Recovery System, or MACRS. For locomotives, the schedule runs 5 to 7 years, which means by the time a unit's a decade old, most of its book value has already been erased on paper. The asset that costs $3 million to buy might carry a remaining book value of $500,000 or less by the time it starts causing maintenance headaches. Before we get into the numbers, we'd love you to come on board and hit that subscribe button. Here's where abandonment becomes interesting. When a railroad formally abandons a locomotive rather than selling it, they can claim what the tax code calls an ordinary loss on whatever book value remains. That loss offsets taxable income, which means the federal government effectively shares in the cost of getting rid of the machine. The tax shield generated by a single abandonment can run between $100,000 and $150,000 per unit, depending on the railroad's tax situation and how much basis remains in the asset. Selling a locomotive does the opposite. When a railroad sells a unit, even at a loss compared to original purchase price, the IRS treats the proceeds as triggering depreciation recapture. All those years of write-offs come back into the picture, and the gain gets taxed as ordinary income. A sale that looks like a money loser on paper can still generate a significant tax bill because of the recapture rules. Abandonment sidesteps this entirely. No sale means no recapture, no gain, and no unexpected tax liability landing on the finance department's desk in April. The people who designed this outcome weren't trying to incentivize locomotive graveyards. Tax law developed over decades to serve many purposes, and the interaction between MACRS, ordinary loss treatment, and depreciation recapture just happens to favor abandonment in the specific situation railroads face. But the effect is real, and fleet managers know it. What looks like waste from the outside often looks like smart tax planning from the inside. Even setting tax considerations aside entirely, a retired locomotive doesn't stop being valuable the moment it leaves regular service. It just changes what kind of value it offers. A single retired diesel unit can yield roughly $260,000 worth of serviceable components when treated as a parts source rather than a disposable problem. Traction motors, which handle the actual work of turning wheels, can be rebuilt and reinstalled in active units. Dynamic brake grids, air compressors, fuel injectors, and cooling system components all have useful lives that extend well beyond the locomotive's practical service as a complete machine. Cab components, control stands, gauges, and electrical panels move from retired units to active ones through a steady stream of shop work that keeps older fleets running longer than their manufacturers intended. This matters because the alternative to cannibalized parts is new procurement, and new procurement is expensive. A new traction motor purchased through official channels costs several times what it would cost to pull one from a stored unit and have the shop rebuild it to serviceable condition. Multiplied across a large fleet with hundreds of active locomotives, the savings from maintaining an internal parts supply becomes substantial enough to justify keeping retired units on hand almost indefinitely. The storage cost makes this strategy even more appealing. Keeping a retired locomotive sitting on a siding costs roughly $3,200 per year when you account for the land, minimal weatherization, and occasional inspection. For a machine carrying $250,000 worth of eventual parts value, that storage cost is nearly trivial. A warehouse storing an equivalent inventory of new parts would cost orders of magnitude more. There's also a less obvious strategic benefit. Locomotive components are often proprietary, meaning only authorized dealers or the original manufacturers supply parts at full price. A railroad that keeps retired units from a specific manufacturer effectively removes those parts from the open market, which means competitors running the same locomotive models can't easily buy them either. The stored units become a competitive advantage disguised as a disposal problem. When a locomotive's parts are worth more than its sale price, selling it whole makes zero financial sense. For railroads that do try to sell retired locomotives, the process quickly reveals a set of barriers that makes the transaction far more trouble than it appears on the surface. The Environmental Protection Agency's emission standards for locomotives had tightened considerably over the decades. Modern Tier 4 standards are dramatically stricter than the rules that governed engines built in the 1990s and early 2000s, which covers a large portion of any railroad's retired fleet. An older locomotive being returned to service in the United States has to meet current emissions requirements, and achieving that certification can cost more than $120,000 before a single dollar of actual mechanical work gets done. For a locomotive that might fetch $150,000 at sale, the certification cost alone can eliminate any profit from the transaction entirely. Export sales seem like an obvious solution, and international buyers do occasionally surface for retired American locomotives, particularly from operators in South America, Africa, and Southeast Asia where older equipment remains practical. But American export control regulations adds 30 to 60 days of paperwork to any sale that crosses an international border, assuming the sale qualifies at all. Locomotives with certain electronic or propulsion technologies may require export licenses, and the process of obtaining those licenses introduces delays and costs that frustrate both sellers and buyers. International deals that look straightforward in initial conversations often collapse somewhere in the documentation process. The most serious legal complication comes from environmental liability. Under the Comprehensive Environmental Response, Compensation, and Liability Act, commonly known as CERCLA, the original owner of equipment containing hazardous materials can remain legally responsible for cleanup costs years or even decades after a sale. Locomotives built before the 1990s often contain PCBs and electrical components, asbestos in gaskets and insulation, and various other regulated substances. If a buyer takes the locomotive, operates it, allows it to deteriorate, and eventually abandons it somewhere that creates an environmental problem, the original railroad can find itself named in a cleanup action even though they sold the unit years earlier. CERCLA liability doesn't care how well structured the sales contract was. It pursues responsible parties based on ownership history, not contractual allocation of risk. Legal departments at major railroads understand this exposure very well. A transaction that generates $100,000 in revenue is not worth the potential CERCLA cleanup liability that could run into the millions. Abandonment on controlled property, while not a perfect solution, keeps the liability situation more predictable than a sale to an unknown buyer with unknown disposal plans. The path from wanting to sell a locomotive to actually selling one turns out to be a legal obstacle course most railroads would rather avoid. Even if the regulatory and tax problems disappeared overnight, railroads trying to sell retired locomotives would still face a market that's been broken for years by simple oversupply. The period following the Great Recession, combined with a slow freight cycle in the mid-2010s and the demand collapse during the early pandemic years, left major railroads sitting on enormous numbers of idle locomotives. Union Pacific, BNSF, and CSX collectively stored hundreds of units during slow periods. When those units eventually came up for disposal, they flooded a market that couldn't absorb them. Locomotives that cost $3 million new were trading for $180,000 to $230,000, prices that approached what scrap metal would fetch if you melted the machine down to raw steel. At that price level, selling a locomotive barely covers the cost of preparing it for sale. Before any transaction can close, a railroad needs to strip proprietary documentation, ensure fuel and fluids meet environmental transport standards, arrange inspection, and handle logistics. That preparation work runs several $100,000 for a unit in average condition. The result is a sale that generates cash proceeds of $150,000 while costing $300,000 to execute, a guaranteed loss on every transaction. Software dependency has made the problem worse in recent years. Modern locomotives run on sophisticated engine management and control systems that require proprietary software for diagnostics, updates, and repair. Manufacturers support these systems for roughly a decade after production ends, and after that, buyers who lack the software infrastructure to maintain the electronics are buying expensive mechanical paperweights. International buyers who express interest in older American equipment frequently walk away when they realize that the control systems are unsupported and that no amount of mechanical skill can substitute for access to manufacturer diagnostics tools they can't legally obtain. A market where buyers can't get what they need and sellers can't recover what they spent isn't really a market at all. Part of the reason locomotive disposal is so expensive and complicated comes down to what's physically inside these machines after decades of operation. Older diesel locomotives are dense with materials that were standard industrial practice at the time of construction and are serious regulated hazardous substances today. Polychlorinated biphenyls, known as PCBs, were widely used in electrical transformers and capacitors through the late 1970s because they resisted fire and degraded slowly. That slow degradation turns out to be the problem. PCBs persist in the environment for decades and accumulate in living tissue, which is why the EPA eventually banned them and requires careful handling of any equipment containing them. A locomotive built in 1975 almost certainly has PCB containing electrical components somewhere in its systems. Asbestos shows up in gaskets, insulation wrap, and brake components manufactured before the mid-1980s. Lead appears in paint applied to exterior and interior surfaces. Mercury can be found in older gauges and switches. Diesel fuel residue soaks into insulation and seeps into structural components over years of operation. Each of these materials requires specific handling protocols during disassembly, and the personnel doing the work need appropriate training and protective equipment. Proper dismantling of a locomotive containing these materials costs approximately $180,000 per unit when performed by a licensed facility following all applicable regulations. That figure includes the specialized labor, hazardous waste disposal fees, documentation requirements, and facility costs. It doesn't include transportation to the dismantling site, which adds to the total depending on location. CERCLA's reach into this process creates additional complications. The law allows enforcement agencies to pursue any party in the chain of ownership when contamination is discovered, which means a railroad that sold a locomotive to a dismantler who improperly handled PCBs can find itself liable for cleanup costs, even if the sale contract specifically assigned environmental responsibility to the buyer. Courts have consistently held that CERCLA liability can't be fully contracted away. Abandoning a locomotive on railroad-controlled property doesn't eliminate these issues, but it does allow the railroad to control how and when they're addressed, rather than exposing themselves to whatever disposal decisions a buyer might make. An old locomotive sitting in a field still contains everything that was inside it when it ran. The problem doesn't go away, it just waits. When a motive power department sits down to decide what to do with a retired locomotive, the analysis looks nothing like the intuitive answer of finding a buyer and collecting cash. The actual numbers consistently point somewhere else. Consider a unit with a remaining book value of $500,000 that the railroad wants off its active roster. Preparing it for sale, clearing proprietary systems, handling fluids, arranging inspection, managing the transaction costs roughly $300,000 in direct expense. The sale itself, in the current market, generates perhaps $140,000 in proceeds. The net result is a loss of more than $160,000, and that's before accounting for any environmental liability that follows a unit to its new owner. Pulling the same locomotive apart for components changes the math entirely. The parts harvested from a typical retired unit provide roughly $210,000 in value to the active fleet, measured against what those parts would cost to procure new. The cannibalization process requires shop labor and some overhead, but it avoids all the regulatory preparation costs of a sale. Net benefit runs well into positive territory. Abandonment on controlled property, combined with the ordinary loss tax treatment, generates a tax shield with more than $360,000 on a unit with the right basis. No certification costs, no export paperwork, no CERCLA exposure from a buyer's future decisions, no market timing risk. The process requires almost no active management once a unit is stored and the accounting entries made. The conclusion fleet managers reach isn't surprising given these numbers. Cannibalization beats selling. Abandonment beats both when tax treatment is favorable. Selling a locomotive whole in the current regulatory and market environment is almost never the right answer unless the railroad has very specific circumstances that make the usual analysis work out differently. The economics of the decision aren't mysterious once you see all the inputs. They just don't match what common sense would suggest from the outside. The individual decisions that railroads make about retired locomotives are rational. The system those decisions produce is worth examining more carefully. Billions of dollars worth of working machinery sits idle in storage yards across the country, not because anyone made a careless or short-sighted choice, but because the interaction of tax law, environmental regulation, export controls, intellectual property restrictions, and a collapsed resale market makes storage and eventual abandonment the financially correct choice at nearly every decision point. Each rule that contributes to this outcome was designed for reasonable purpose. MACRS depreciation reflects real economic wear and provides predictable cost recovery. CERCLA liability exists because companies genuinely did abandon hazardous waste and leave cleanup costs to the public. Modern emission standards protect air quality and public health. Export controls address legitimate national security concerns. Software licensing rules protect proprietary technology and cybersecurity. But the combination of all these reasonable rules creates an incentive structure where destroying useful capital is often the most rational thing a large company can do with it. The tax code can reward abandonment over sale by triggering depreciation recapture that erodes already thin resale margins. Liability law can make transfers of ownership legally fraught, discouraging secondary markets. The regulatory costs of returning older equipment to service, retrofitting emissions systems, certifying compliance, securing parts and documentation often exceeds its market value. Secondary buyers may find themselves unable to access the diagnostic software or firmware updates necessary to maintain what they purchase, turning an asset into a liability. None of these outcomes was the goal of the underlying policies. All of them are predictable consequences of how those policies interact in practice. Whether the policy ought to change is a genuine question without an obvious answer. Reforming depreciation recapture rules to be less punitive on locomotive sales would require weighing the revenue cost against the environmental and economic benefit of more active resale markets. Adjusting circular liability for structured sales to qualify dismantlers or rebuilders might encourage proper disposable and refurbishment over indefinite storage, but designing the right carve-out without creating new loopholes is harder than it sounds. Making software access a condition of sale would require either regulatory mandates on manufacturers or the development of industry standards that don't currently exist. Each potential reform carries trade-offs, administrative complexity, and the risk of unintended consequences. The locomotives rusting in those storage fields aren't evidence that railroads are uniquely irresponsible or indifferent to waste. They're evidence that a system built from individually sensible rules can produce outcomes that look irrational when viewed in aggregate. No single decision is obviously wrong. The pattern they create, however, invites a broader conversation about how policy design shapes capital allocation and how easily value can be stranded in plain sight. The next time you see a line of dead locomotives sitting behind a fence, you're not looking at neglect. You're looking at the output of a tax code, an environmental liability regime, an emission certification system, and a broken resale market, all pointing in the same direction at once. The railroads didn't choose waste. The math chose it for them. Hit that like button and subscribe for more stories about how the machinery of industry actually works and why it so often works in ways that surprise everyone watching from the outside.